KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.com.
See here, ma. So with our previous class, last class, we completed alternating current numericals. Example, exercise, additional exercise. All three model problems, numericals we completed regarding alternating current with the last class. In this class, we are going to start a new chapter to discuss numericals, that is electromagnetic waves. Electromagnetic waves. Okay, right. See here. First, example problems. Adikapram we will start exercise problems. After that, we will start additional exercise. Okay, right. So now we are going to discuss example problems. This is what the first example problem, that is example 8.1. Example 8.1. Okay, right. See here. A parallel plate capacitor with circular plates of radius 1 meter has a capacitance of 1 nanofarad. A parallel plate capacitor with circular plates, a parallel plate capacitor with circular plates of radius 1 meter has a capacitance of 1 nanofarad. Okay, right. So we have to understand that there is a parallel plate capacitor with circular plates. You know what are the plates of a parallel plate capacitor? We may have different types of shapes, but there is a relevance. There is a relevance regarding the shape of the plate. But here in this problem, in this situation, we have to imagine a circular plates of radius 1 meter has a capacitance of 1 nanofarad. Okay. So nanofarad is not the SI unit, no. So nanofarad is the unit. If you want to convert into SI units, there you can convert into farad. That is what 1 nano is 10 to the power of minus 9, no. So here the capacitance of parallel plate capacitor in circular shape is 10 to the power of minus 9 farad. Okay, 1 nanofarad in SI, 10 to the power of minus 9 farad, full stop. At t is equal to 0, at small t is equal to 0, it is connected for charging in series. At t is equal to 0, it is connected for charging in series with a resistor capital R is equal to 1 million ohm, that is what 1 mega ohm, right? That is what 10 to the power of 6 ma. Resistor is 10 to the power of 6 ohms, right? Across a 2 volts battery, this is what figure 8.3 means this is the figure. Across a 2 volt battery, right? This is the 2 volt battery and it is a resistor of resistance 1 mega ohm or million ohm, that is what 10 power 6. And okay, right, it is like a plug key and it is the battery, it is the resistor, right? Here we have plates. Calculate the magnetic field at a point P. Calculate the magnetic field at a point P halfway between the center and the periphery of the plates. This is the center, it's the periphery of the plates, right? So calculate the magnetic field at a point P. See, he is indicating where is the P, right? So calculate the magnetic field at a point P halfway between the center and the periphery of the plates. Right? after t is equal minus 3 seconds. After t is equal minus 3 seconds. Okay. So once if you look at from here onwards, that is what at t is equal 0, it is connected. At t is equal 0, it is connected for charging in series with a resistor R is equal to 1 million ohms across a 2-volt battery, right? Full stop. Calculate the magnetic field. Calculate the magnetic field at a point P halfway between the center and the periphery of the plates. Periphery of the plates. After t is equal 10 to the power of minus 3 seconds. After t is equal to 10 to the power of minus 3 seconds. Full stop. Right. The charge on the capacitor at time t is, the charge on the capacitor at time t is q of t is equal to, q of t is equal to Cv into 1 minus exponential minus small t by tau, minus small t by tau. Okay. Right. This is what they have given in the bracket. But the time constant is equal to Cr, that is what already in the bracket, that is where the time constant, it is the time constant now. Time constant tau is equal to C into R. That is also like a given thing. Now what I am saying is, it is the picture already he described the picture what is there, and I also told you that is what is the plug key and what is the battery and what is the resistor, right? So resistor, battery, plug key and the capacitor plates. Capacitor plates all are connected to one to other. They also given some of the values, that is what area of the circular plate is of radius 1 meter and capacitance is 10 to the power of minus 9 farad. 10 to the power of minus 9 farad. Okay, right. Now the time constant of the CR circuit is, the time constant of the CR circuit is tau is equal to CR is equal to 10 to the power of minus 3 seconds. That is already given, just he is writing. Then we have, so what we have, q of t is equal to Cv into 1 minus exponential minus t by tau. Am I right? Already given function, that is what charge on the capacitor at time t is equal to q of t is equal to C is the capacitance, right? See, this is what small t is the time and tau is the, that is time constant, and V is the potential difference like. Okay. So it is what capacitance, that is what 2 into 10 to the power of minus 9, 2 into 10 to the power of minus 9 into, why? Because why here 2 into 10 to the power of minus 9? See this, what is the potential difference of battery? See, it is 2, no? What is the C? It is 10 to the power of minus 9 farad, no? I already told you. So 2 into 10 to the power of minus 9 is the value of Cv into bracket 1 minus exponential of minus small t by 10 to the power of minus 3. That is what tau value in the bracket and bracket close. Now the electric field in between the plates at time small t. The electric field in between the plates at time small t is capital E is equal to q of t by epsilon naught into A. That is equal to q by pi epsilon naught. Q by pi epsilon naught. It is what q by epsilon naught. It is A, no? So that is equal to q by pi epsilon naught. See that here what is A? A value is pi into 1 square. Pi into 1 square. Actually A is pi r square, no? So what is R? R is 1 meter, no? See here, radius of 1 meter has, right? So when A is, when R is equal to 1, then what is the A value? Pi only, no? That's why in place of A they have written pi. Okay, that is the reason. We have to understand that why here in place of A he has written pi means A value became as pi by substituting the value radius of the circular plate, that is A is equal to pi. Now see, consider now a circular loop of radius 1 by 2 meters. Consider now a circular loop of radius 1 by 2 meters. See, parallel to the plates passing through P. Consider now a circular loop of radius parallel to the plates passing through P. Full stop. The magnetic field B at all points, the magnetic field B at all points on the loop is along the loop and of the same value, okay, right. Once again I will repeat ma. Consider now a circular loop of radius 1 by 2 meters, in the bracket 1 by 2 meters, parallel to the plates passing through P, full stop. The magnetic field capital B at all points on the loop is along the loop and of the same value. Please try to understand what I am saying ma. Consider now a circular loop of radius 1 by 2 meters parallel to the plates passing through P, full stop. The magnetic field capital B at all points on the loop, is along the loop and of the same value. Please try to understand. Now, the flux phi E through this loop is, this is what Gauss law, you know very well. The flux phi E, right, the flux phi E through this loop is, phi E is equal to E into area of the loop, right. So what is E, right, as it is, and area of the loop is pi r square now. So pi into r value is 1 by 2 now. See, consider now circular loop of radius 1 by 2 meters parallel to the plates passing through P. The magnetic field B at all points on the loop is along the loop and of the same value. Now it is what, 1 by 4 no. So finally what we are getting? Pi E by 4. That is equal to Q by 4 epsilon naught. Pi E by 4, that is equal to Q by 4 epsilon naught. Small q by 4 epsilon naught. Now the displacement current ID is equal to epsilon naught into d phi E by dt. That is equal to 1 by 4 into dq by dt. ID is equal to epsilon naught into d phi E by dt. That is equal to, because what is phi E? Q by 4 epsilon naught no. See here ma. Already epsilon naught is there. In place of phi E we have to write q by 4 epsilon naught. So epsilon naught will get cancelled. Finally the answer will become 1 by 4 into dq by dt. 1 by 4 into dq by dt. That is equal to 0.5 into 10 to the power of minus 6. 0.5 into 10 to the power of minus 6. Right? Exponential of minus 1. Now what I am saying is, at t is equal 10 to the power of minus 3 seconds. At t is equal to 10 to the power of minus 3 seconds. Right? At t is equal 10 to the power of minus 3 seconds. This is what this is the value. At small t is equal 10 to the power of minus 3 seconds. This is the value of ID, right? Now applying Ampere Maxwell law to the loop. We get B into 2 pi into 1 by 2. B into 2 pi into 1 by 2 is equal to mu naught into IC plus ID. B into 2 pi into 1 by 2 is equal to mu naught into IC plus ID. That is equal to mu naught into, what is IC? That is 0 no. We have only ID value. Right? So we are going to substitute the ID value, that is 0.5 into 10 to the power of minus 6. So mu naught 0.5 into 10 to the power of minus 6 mu naught into exponential of minus 1. B into 2 pi into 1 by 2 is equal to mu naught into IC plus ID is equal to mu naught into 0 plus ID. That is equal to 0.5 into 10 to the power of minus 6 into mu naught into exponential of minus 1. Or capital B is equal to 0.74 into 10 to the power of minus 13 Tesla. Capital B is equal to 0.74 into 10 to the power of minus 13 Tesla. This is what the field, the value of magnetic field. And that he is asking that only no. See, in this problem what he is asking from starting onwards we are observing no. What he is asking? So he is asking the calculate the magnetic field at a point P halfway between the center and the periphery of the plates after t is equal to minus 3 seconds. So we used the time value also, that is what 10 to the power of minus 3 seconds we used. So by using that value only we got displacement current as 0.5 into 10 to the power of minus 6, 0.5 into 10 to the power of minus 6 mu naught exponential of minus 1, or capital B is equal to 0.74 into 10 to the power of minus 13 Tesla, 0.74 into 10 to the power of minus 13 Tesla. Okay, right. Next problem, see this, that is what continuation to this 8.1. Next problem is 8.2. no, example 8.2. see here, a plane electromagnetic wave of frequency 25 megahertz, that is what 10 to the power of 6. no, mega means it is 10 to the power of 6. A plane electromagnetic wave of frequency 25 megahertz travels in free space along the positive x direction, because suppose if we have written minus means it is negative x direction, but nothing is there means positive, no, positive x direction, full stop. At a particular point in space and time, E is equal to, E is electric field, no, it is a vector, no, right, E is equal, so you can put bar also, no problem. E is equal to 6.3 into J cap volt per meter. Okay, right. And one more point I want to say here, that is what representation of a vector quantity. Okay, right. So how to represent a vector quantity? Just by using a letter which is used to represent the physical quantity, and by writing the arrow mark on the top of the letter, we can say that it is a vector quantity like this. Okay. Otherwise, just by writing a thick letter also, you can say that it is a vector quantity. Okay, that's what we learned from CBSE 11th syllabus. That is what motion in a plane chapter we got vectors concept, no, right? So there we got the concept related to representation of a vector quantity. So while representing a vector quantity, we can use, that is what a thick letter that is what thick bold letter. Otherwise, you can use, you can write arrow mark on the top of the letter to represent a vector quantity. Okay, right. Now, what is B at this point? E is equal to 6.3. That is what J cap. J cap means along positive y axis, no, y axis volt per meter. What is capital B at this point? What is capital B at this point? Okay, right. Now, solution. See here. Using equation B naught is equal to E naught by C. Using equation B naught is equal to E naught by C. The magnitude of B is B is equal to E by C. This is what we know from our discussion of theorem. B is equal to E by C. That is the relation between magnetic field and electric field regarding the electromagnetic wave. So what is electromagnetic wave? Electromagnetic wave consists of oscillating electric field and oscillating magnetic field, and these two fields are oscillating perpendicular to each other and also perpendicular to the direction of propagation. Okay, that is right. So what I am saying is here, when B is equal to E by C, E value they have given, that is what 6.3 volt per meter, and C value 3 into 10 to the power of 8 meter per second, that is equal to 2.1 into 10 to the power of minus 8. 2.1 into 10 to the power of minus 8 Tesla. This is the value of magnetic field. Right. Now, to find the direction, because magnetic field is a vector quantity, no? Magnetic field is a vector quantity, right? To find the direction, we note that E bar is along y direction and the wave propagates along the x-axis. To find the direction, we note that E bar is along y direction and the wave propagates along the x-axis. Full stop. Therefore, B should be. This one I need not to say separately, just by seeing the letter you can understand. See, E is equal to 6.3 j cap means that is what along positive y direction. No, I told you when I was explaining the problem initially, I told you what is the notation of this j cap. After completion of that, see what is the wave propagates along the x-axis, right? I told you the definition of electromagnetic wave just now, and what it consists and how it propagates, and what is the angle between the oscillating electric field and oscillating magnetic field, and what is the angle between oscillating electric field and direction of propagation, and what is the oscillating magnetic field and direction of propagation, and totally what is the angle between all of this. All of this means the components are only two, oscillating electric field and oscillating magnetic field, but there is also direction of propagation. No? So all are like mutually perpendicular to each other, right? That's what I want to say. Therefore, B should be in a direction. Therefore, B should be in a direction perpendicular to both x and y axis. Perpendicular to both x and y axis. Full stop. Using vector algebra. Using vector algebra, E bar cross B bar. E bar cross B bar should be along x direction. Should be along x direction. Since plus j cap cross plus k cap, plus j cap cross plus k cap is equal to I cap, is equal to I cap. So finally he is saying B bar is along the positive z direction, that is B bar is equal to 2.1 into 10 to the power of minus 8 k cap Tesla. So k cap is indicating that the B bar is along the positive z direction. B bar is along the positive z direction. Okay, that's what I want to say. So in this class we discussed two example problems. No? One is example 8.1, another one is example 8.2. So in example 8.1 they have given one parallel plate capacitor consisting of the plates in circular shape. The plates in circular shape. And he is saying that at time t is equal to 0, it is connected for a charging in series with a resistor R is equal to 1 mega ohm across a 2 volt battery. Now then he is asking to calculate the magnetic field. He is asking to calculate the magnetic field, that is what asking to magnetic field at a point P, halfway between the center and the periphery of the plates. Okay. Right, about t is equal to 10 to the power of minus 3 seconds. That is also important. No, when time changes, that value will be changed. And in the bracket, they have given expression for charge on the capacitor, and then where the time constant tau is equal to CR. Right. So this is the circuit already given as a part of question. Otherwise, you can draw based on the given information. Here, the time constant of the CR circuit is CR circuit is tau is equal to CR, that is equal to 10 to the power of minus 3 seconds, full stop. Then we have Q of t is equal to CV into 1 minus exponential minus small t by tau. So that is what CV value according to the given information, according to the given data. You can write this value into 1 minus this one, and tau already mentioned at 10 to the power of minus 3 seconds, right. Now the electric field in between the plates at time small t is equal to, right, this is what the electric field we got, and then afterwards we got the flux through this loop of phi e is equal to as q by 4 epsilon naught. Then the displacement current ID will become like this, 0.5 into 10 to the power of minus 6 exponential of minus 1 at t is equal to 10 to the power of minus 3 seconds. So by using Ampere Maxwell law, we found out, that is what magnetic field we determined or we calculated, that is what 0.74 into 10 to the power of minus 13 Tesla. Next example 8.2. So here a plane electromagnetic wave of frequency 25 megahertz travels in free space along the positive x direction. At a particular point in space and time, this is E value, and he is asking B value, right. So using this equation, B naught is equal to E naught by C, the magnitude of B is equal to E by C, that is equal to 2.1 into 10 to the power of minus 8 Tesla. So this is what magnitude we determined. Next, to find the direction, To find the direction, we note that E bar is along y direction and the wave propagates along the x axis. Therefore, B should be in a direction perpendicular to both x and y axis. Using vector algebra, E bar cross B bar should be along the positive x direction, since this is what, right? So you can say that B bar is along the z direction. Thus, you can write notation B bar is equal to 2.1 into 10 to the power of minus 8 K cap Tesla. Okay, right. So in our next class, we will continue with example 8.3. Thank you.